So got cut off on that last one we were working on, but we had A2, A3, and then we were finishing up here for A4. So 8x plus 2x is 10x. And negative 7 minus 5 more is going to be negative 12. So it's like, remember, you always plug in the prior term when you're using recursive to get to the next term. Now, when I look at number 7, this one, do not make it anything too hard for yourself. You have the graphing calculator. Let's utilize it. So y equals e to the x. And we can look at what that graph looks like together. Okay, so we can go and see what the descriptions say and which one our best answer is. So it's asymptotic to the x-axis. That's true, right? Because that's just saying that my asymptote is the x-axis. So, yeah, we're looking for not true, though, so one's out. The domain is all real numbers. That's true, too. Domain, remember, is the x's left and right. It goes on forever, left and right. It lies in quadrants 1 and 2. So, remember, quadrant 1 would be the upper right-hand corner. And then quadrant 2 is the upper left-hand corner. So yes, that's true too. So it has to be choice 4. And when I look at my table here, 0, 1, that's true for all exponentials. It should pass through the point 0, 1. Okay? And if you look at the graph, you'll be able to follow up. Now, I want you to go ahead and plug in 8 into your calculator. Same thing, y equals 2 raised to the x plus 1 minus 3. But when we go to graph it, remember, we only care about these points. There should be no arrows in your graph. So go ahead and pause the video and take a second just to put that in your calculator. Graph that looks like this. So remember, I plugged this in y equals right into my graphing calculator. I hit second graph to see the table. I wrote at the table just so you could see it. You could show it here, but the big thing is we only care about the domain being from -2 to 2. So I would plot those points and stop. Notice there's no arrows. It's not going on forever in this case. It's only starting at -2 and ending by 2. It shouldn't go any further. Okay. When we evaluate something like this in number 9, that's our sigma notation. So you're plugging in the 3 for n for the first one. And I would then plug in 4. And I would keep going until I get to the end. Then I know that the end number is 7. So I would plug in 4, 5, like 3, 4, 5, 6, 7. But because it just says evaluate, you don't really have to show work on this one. If it says expand and evaluate, I need you to show what you're plugging in and how you get it. But we can use the calculator here. So I'm going to go to alpha window again, and you'll see summation. That's the same as our sigma notation. And I'll just call this one x equal to 3. I'll go up to 7, and I'm going to plug in 3x, just remind myself what it said, plus 5. And we'll get 100. So you're plugging in, you're adding all those pieces up to get the sum. So you should have gotten 100 for that one. Okay. The minimum point of the graph of the equation of f of x is -1, -3. What is the minimum point of the graph of the equation of f of x plus 5? So this is the current minimum. This is telling us that there is a vertical shift. So it's going up 5. So if this point, -1, -3, is going up 5, that's shifting every point in the positive up direction. So the y is going to be up 5. So the new point should be -1, 2. Okay, graph log base 3, x plus 7 minus 4 on the set of axes below. Use an appropriate scale to include both intercepts. So I'm going to just use the graphing calculator again here. When we're plugging that in, we go to y equals alpha window 5 log base 3. Let me remind myself it was x plus 7 minus 4. And I'm going to graph. Now we are looking for both intercepts in this case. So we know the first one, 0, negative 2.229. No problem. Remember here, you have to play with your window. So if I look at my graph, I could do zoom out. It looks like it's getting closer. I might even zoom out a little bit more. Now, I'm going to use this trick. Second, calculate. We're trying to find the 0. So I'm going to see how I have negative values of y right here. I want to make sure on the left it's still negative, so I'm just going to enter anywhere. But now I'm going to go to the right until I see positive numbers. Because I know it's somewhere in between. 0 has to fall between negative and positive. So I make my 3 guesses, and it tells me that it's at 74. So I know that I have to have the x-intercept of 74 and 0. And we had 0, and let me just remind myself what we had in the beginning there. Second table, 0 and negative 2.229. So in this case here, I can just get some of those points to nicely graph, but things that I care about, I know that I have to get up to 74 to get the asymptote, so I'm probably going to count by 7s. Oh, just kidding, 8s. Okay, and I could write it all out, but I'm just going to say that I'm counting by 8s, so that way I know. Same thing would be negative 80 on this side. Now, remember, this negative 4 is the same as telling me where my asymptote is. So it's never going to pass this line here. So I want to show my asymptote, my x equals negative 4. And we'll get some points here that would have graphed nicely. Like if I look at my table, I have 2 and negative 2. See if there's any nice ones that pop up. 20 and negative 1. So it's going to be slow because remember we're looking at it, it's going to go pretty slow, but we know here, as long as like in this case, we're showing that that's 74, right? And then 20, and we would have negative 1. So we're looking at a log roughly like this. Okay, last one. This one's just about reading the problem and plugging in correctly. So we have Kaylee's looking to take out a mortgage for $40,000 from a bank offering a monthly interest rate, of 3.6%. If Kaylee takes out a loan from the bank for 6 years, how much will her monthly payments be to the nearest cent? So we want to know what her monthly payment will be. So we don't know M, so that's okay. We're starting there. Now, P is the amount that's borrowed. So since we're borrowing that, P is this, because she wants to take out a mortgage for $40,000 from the bank. So that's our 40,000 here. Now, when we go to find R is the interest rate per month. So remember, we do convert that back though, so 0.036. And we'll have 1 plus that. Just rewrite it so it's clean there. And N, it's going to be here, we have to be careful. So N is talking about the monthly number of payments total, but we're doing it for 6 years. But 6 years, we're looking at a monthly rate. So we're doing 6 times 12. So we get 72 there. And then we just fill out the bottom as well. So now we know all of our pieces. 1 plus that rate. Okay. Once we have all of that together, now it's just a matter of plugging it in to the nearest cent. So everything here is just going right in the calculator. Second quit. Alpha y equals 40,000 0.036. 1 plus 0.036 raised to the 72. And just remind myself what the denominator was. 1 plus 0.036. Put that in parentheses. To the 72 minus 1. So my payments to the nearest cent would be $1,562.43. Okay, guys, if you have any questions about this or review, like either parts of the review videos, shoot me an email at any time. I'll do my best to help you through it, and we'll get ready for our quarterly. Okay. Hope to see you guys soon.